Assalamualaikum warahmatullahi wabarakatuh. Sesyahadan, my name is Nur Anis Najwa binti Rosli. My ID number 20211602009. My position as a network security specialist. So we start to the introduction. The purpose of this chapter is to provide an overview of Wlan design and to explain how they contribute to modern business, communication and data flow. In the following section, the project outline the group goals, including incorporating machine learning to detect malware within a wireless local area network. This introduction briefly discussed the pros and cons of this approach, but the main focus shift to Wlan design considerations such as coverage and network performance. For the purpose of including the chapter, aim to provide context for the further analysis and discussion for this element. Project background. So, Bellatrix Connection has experience designing wireless local area network for small businesses in multi-story buildings using simulation software. So hardware placement, topology, and IP addresses strategy should be determined by a network diagram. So the Wlan design project background will help you understand specific requirement and consideration. Okay, 1.3 problem statement. We have an issue for the wireless network in our office building, which causes employees to use wired connection. With a new robust connection network, we can achieve a seamless roaming across floors. Then the high-speed connectivity, security and flexibility. So the project will focus on the following key areas. We have 3 for the number 1. Identify gaps in coverage and interfering signal. Number 2, network design can be optimized using various methods. The last one is upgrade the being made to the hardware infrastructure. Okay, for the 1.4 objective, the purpose of wireless local area network is to optimize the productivity, flexibility, scalability, and customer experience of businesses by meeting the following primary objective. Okay, for the first one, support client application such as laptop, smartphone and printers. Number 2, support persistent roaming over the wireless network for legacy and new devices. Number 3, ensure reliable performance and persistent roaming over the wireless network across the facility. Then install the wireless equipment and area can be easily accessed by local IT. Then analyze of the signal strength, signal to noise ratio, and network performance metric. Number 6, setting up the separate SSID for the conference room. Next, analyze wireless technology IP address and wireless standard for the proposed solution. Lastly, number 8, define how the wireless network works. Alright, we moving on to another slide is 1.5 significance. Due to difficulties with wireless connection in our office, employees are forced to use wired connection in order to perform their tasks efficiently. So as part of our effort to provide seamless roaming across floors, high-speed connectivity, security and flexibility are designing a new robust wireless network. So these several factors may contribute to the significance of the project, including for the first one is enhanced connectivity with the optimized Wlan infrastructure. The organization can make sure that users are always connected to application and network resources. For number 2 is improve productivity. So the Wlan enable efficient and effective collaboration by providing high-speed internet connection. For number 3, security. Machine learning method can be detect malware, protecting sensitive and data system. Number 4 is flexible scalability. Wlan are carefully designed to grow with your business. Number 5, cost efficiency. So the network performance and security optimizing, reduce maintenance costs and downtime. Last but not least is innovation. The network demonstrates its commitment to innovation and staying ahead of cybersecurity threat of the machine learning. So overall, the Wlan design project contribute to the transformation of the organization network infrastructure. It's enhanced operational efficiency, improve security measure, and support future growth.
Assalamualaikum, my name is Nordini binti Muhammad Noor. My student ID is 2021152235. My position is network analyst. Today I'm going to present about literature review. Literature review will explain about the wireless local area network. Wireless local area network is a network made up of collocated computer or other device that use radio transmission instead of wired connection. Yearly, IEEE introduced 802.11 standard for wireless local area network due to the rapid increase in the human demand of wireless network worldwide. Its required efficiency for the current generation, IEEE introduced the 802.11e standard for quality of service in 2005. Over the years, the IEEE 802.11 standard has been updated and expanded through various amendments to support highest data rate, improve security, and increase efficiency, leading to the development of widely known Wi-Fi versions such as 802.11a, 802.11b, 802.11g, 802.11n for Wi-Fi 4, 802.11ac for Wi-Fi 5, and 802.11ax for Wi-Fi 6. Okay, for the next part, I will explain 2.1, which is WLAN technologies. When established a wireless local area network throughout a 3-story structure for a small business, various WLAN technologies and standards are used to guarantee effective, safe, and all-encompassing wireless coverage. In this project, we use IEEE 802.11ax, which is Wi-Fi 6. Compared to Wi-Fi 5, it is intended to be faster, more efficient, and have more capacity with quicker and more dependable wireless communication. This improvement makes Wi-Fi 6 perfect for high-density area. Access points are placed strategically throughout the building, with one extra AP for visitor used in the conference room to reduce interference, particularly in area where coverage overlap. AP choose distinct wireless channel. The last one, for effective traffic control and security, the network is divided into several subnets, possible only for each department of law. By separating departmental traffic, this IP address technique improves security and streamline network management. I will explain 2.2 hardware for WLAN. First one is a Cisco Meraki MX75 router. The Cisco Meraki is a security appliance that is cloud managed and provide integrated firewall, VPN, and other security capabilities, and managed by the Meraki dashboard. The next one is a WatchGuard Firebox T85 firewall. The WatchGuard Firebox is a high-performance, compact network security device, along with intrusion prevention, antivirus, anti-spam, web filtering. The third one is the TP-Link AX 1800 access point. Business wireless connectivity is made quick and easy with the TP AX 1800 wireless dual band access point. A Wi-Fi 6 device, it's offer dual band speed up to 1800 Mbps. The next one is a Cisco Catalyst 2960-48TT switch. This switch It has 48 port switch designed for enterprise network. In order to safeguard the network, it provides layer 2 switching, high performance capabilities, quality of service. The last one is a Canon Maxi 5 GX2070 printer. This printer is a high performance printer, offer affordable printing together with straightforward wireless setup. Next, I will explain 2.3, which is software for Wlan. First is for WatchGuard System Manager. WSM is for the use of handle the Firebox T85 firewall. Administrator can set up track and oversee the security policies and service that are operating on the Firebox T85 through this administration interface. The second one, we use Cisco Meraki dashboard. The Meraki dashboard for managing a Cisco Meraki MX75 router provide a centralized cloud-based interface for configuring, monitoring, and managing the MX75 security appliance. The next one is a Bitdefender antivirus. Bitdefender antivirus is a complete cybersecurity solution that protect Windows, Mac OS, and from malware, ransomware, phishing, and online fraud. Last one, we use TP-Link Omada's SDM platform. It's a centralized control and monitoring of TP-Link network device, which is access point made possible via the cloud-based Omada platform, which provide network management service. It has capabilities like intelligent network analysis for performance and use insight, zero-touch provisioning for simple deployment.
Hi, my name is Nur Nazira. My metric number is now 2021936867. Today I want to present about the Wlan design. The primary objective of the wireless LAN design is to provide seamless and security wireless connectivity within three-story main office building of the company. The design aims to create to the specific need of different departments, ensure scalability for future growth, and adhere to budgetary constraints. Next is I want to present about network requirement. Below is the info table for access for information at ground floor. First is a signal strength at least negative 7.0 dB. A higher negative dBm value is means that close to zero indicate a stronger signal. Negative 0.0 dB is a good signal strength. Next is the signal to noise ratio. This is the ratio of the signal strength to background noise. A higher SNR such as 10.0 dB indicates a better quality signal with less interference. Next is data rate at least 14 Mbps. B is the rate at which data is transmitted over the network. A minimum data rate of 14 Mbps indicates a reasonable fast connections. Next is number of access points. In this flow, access points are divided that allow wireless device to connect to a wired network. This ground floor, we set 5 access points. Each department gives good coverage for the area. We divide AP by trust cell department, meeting room, manufacturing department, shipping and receive departments. Segmenting the VLAN will reduce network congestion and improve overall performance. Next is a ping round trip time at most 10 ms. Ping round trip time is the time it takes for a signal to travel from the source to the destination and back. A low round trip time of ms indicates low latency and quick responsiveness. Last is a packet loss at most 5.0%. Packet loss occurs when data packet transmitted over the network do not reach the destination. Keeping packet loss below 5.0% ensure reliable data transmission. Next is the info table of access point information at first floor. This is the same as a ground floor, but the difference is number of access point is 2. Access are divided, allow wireless device connect to wired network. This ground floor will set to access point for each department suggest good coverage for the area. We divide AP by department R&D department, information technology. Segmenting the VLAN will reduce network regression, network congestion, and improve overall performance. Next is the table info about access information in second floor. This is the same as a ground and first floor, but the difference is number of access point in is two. Access point are devices that allow wireless device to connect to a wired network. This ground floor we set two access points for each department, suggest good coverage for the area. We divide AP by department, finance and department administrator. Segmenting the VLAN will reduce network congestion and improve overall performance. Next is the capacity. In this table, we can see the distribution of devices across different floors of the building. On the ground floor, there are 25 laptops, 25 smartphones, and 3 printers. The first floor has 10 laptops, 10 smartphones, and 2 printers. Moving to the second floor, there are 30 laptops, 30 smartphones, and 2 printers. This information is crucial for understanding the capacity and device distribution through the building. It helps in planning and optimizing resources based on the need of each floor. For instance, the second floor has a higher quantity of devices, indicating a potentially higher demand for network resource and infrastructure. Next is the coverage area. This figure below explains how non-wireless coverage each floor area can receive. As you can see, a coverage area of 2,531 units, 31 meters. This means that the total area of the ground, first and second floor that is covered by the Wi-Fi network, or the totally physical area of the each floor is 2,531 meters. Floor plan. This floor plan represents a well-organized commercial or industry building with a Wlan design. It's divided into distant area. It's designed for a specific purpose and equipped with an access point. First, we can see comprehensive coverage. Access point is placed in each department, ensure every corner of the floor has a strong wireless signal. Next is efficient load distribution. Prevent network congestion by evenly distributing the load among access points, optimizing bandwidth for a seamless connection. Next is the uniform coverage area. Ground floor, floor 1 and floor 2 have an identical coverage area of 2,531 sequence meter, ensuring a consistent and robust through buildings. Next is VLAN segmentation. Each department operates on its VLAN, reducing interface and congestion, enhancing security, and ensuring effective data flow within the network. Last is proactive network management, regular monitoring of signal strength, addressing interface, and optimizing access point configuration are crucial for a stable and reliable wireless network. In this slide, you can imagine how the flow plan by the floor in our company based on the diagram below. This is access point information. Introduction our access point. We use TP-Link Archer LX73 operation on both 2.5 GHz and 5 GHz channels with a maximum client capacity of 8.0. This is Wi-Fi 6, which is 1.11 AS. Device offer impressive speed, reaching up to 574 Mbps on the 2.4 GHz band and outstanding 4,804 Mbps on the 5 GHz band. Ensure robust security, the SSID is Wi-Fi, dash staff and guests, employing WPA3 PSK authentication tailored for residential use. They are designed for three-bedroom house and their IP address will align with our network addressing. And last is the next level connectivity for our staff and guests. Next is logical network diagram. Our network topology is meticulously crafted to meet our organization's connective needs. It starts with the ISP modem, converting the internet signal from semblance to a certain router managing NAT, DHCP, and routing, adding an extra layer of security, a firewall safeguard against potential threat and unauthorized access. For our internal connectivity, fiber optic link connect the central switch to individual floor, switch creating a recently backbone. Wired connections ensure high-speed data flow and from device like PC and laptop on each floor. Wireless connectivity is integrated with strategically placed wireless access point on each floor, providing Wi-Fi coverage of laptop and mobile devices. The combination of wired and wireless options ensure comprehensive network access. Next is the ground floor SSID. This network diagram shows a W line set up across the ground floor of a building. Each department such as gas, cell, meeting room, manufacturing, and shipping and receipt has its own SSID, Service Set Identifier, which is the name of a Wi-Fi network. These SSID are gas at Bellatrix department sets at balance connection, and so on. Having a unique SSID for each department helps to organize the network, improve security, and manage network traffic effectively. For example, guests can connect to the guest at Bellatrix network, which could have different access restrictions compared to the network used by the department. This setup ensures comprehensive Wi-Fi coverage and effective network load distribution across the entire floor. It also enhances network performance and security by the network into different VLANs. Next is the first floor SSID. This network diagram shows a W line set up on the first floor of a building. It has two departments, R&D and Information Technology. Each department has its own SSID, which is the name of a Wi-Fi network. This SSID are DEPT-RND at Bellatrix and DEPT-IT at Bellatrix Connections. Having a unique SSID for each department helps to organize the network, improve security, and manage network traffic effectively. For example, the R&D department can connect to the DEPT-RND at Bellatrix network, which could have different access restrictions compared to the network used by Information Technology Department. This setup ensures comprehensive Wi-Fi coverage and effective network load distribution across the entire floor. It also enhances network performance and security by segmenting the network into the different VLAN. Second is floor SSID. This network diagram shows a WLAN wireless set up on the second floor of a building. It has two departments, finance and administrative. Each department has its own SSID, which is the name of a Wi-Fi network. Having a unique SSID for each department helps organize the network, improve security, and manage network traffic effectively. For example, the finance will connect to the department desk finance at Bellatrix network, which could have a different access restrictions compared to the network used by the administrative department. This setup ensures comprehensive Wi-Fi coverage and effective network load distribution across the entire floor. It also enhances network performance and security by segmenting the network in four different VLANs. Next is network diagram. This table shows the network setup for the different departments in our organization. Each department has unique network address and VLAN name. The network address is the IP address range assigned to that department, and the VLAN name is the unique identifier for the virtual network of the department. This setup helps in managing network traffic effectively, improving security, and ensuring each department has its own dedicated network resource. In my last part, I want to explain about special requests and considerations. As a part of network design, we need prioritize guest network isolation and security through VLAN implementations. Ensure scalability for future expansion. We have planned for seamless growth, signal coverage, strategically optimized, and our network design comply with rigorous regulatory standards. These considerations guarantee a robust, secure, and complete network infrastructure. That's all for me. Thank you.
Hi, Assalamualaikum. My name is Wan Muhammad Mukri bin Wan Abdullah. My metric number is 2021171217. So I will present for the chapter 4 for this proposal. So the 4.0 is the result and the analysis. This section goes into the details, finding and analysis of our wireless local area network, WLAN. The finding cover critical performance indicator including as signal intensity, signal to noise ratio, data rate, and access point dispersion among departments. Following that, we delve deeper into various areas of WLAN performance, including signal strength and coverage, signal noise ratio (SNR) analysis, signal strength varies by access point, and network performance assessment. So, for the signal strength and coverage, signal strength is how strong a wireless signal is, and coverage is how far it reaches reliability. Good signal strength and coverage mean device can communicate well. This ensure consistent communication of wireless device. Next is SNR, or signal to noise ratio. Signal quality is determined by comparing the strength of the desired signal to background noise. Higher signal quality is shown by a greater signal to noise ratio, while lower signal quality is indicated by lower SNR. Next is signal strength by access point. AP or access point are important for getting the best signal and coverage. To ensure good coverage, minimize area without signal, and improve network performance. You need to keep an eye on adjust the strength of the AP signal. The next is network performance. A network performance depends on how fast, reliable, and satisfying it is for users. To make it great, you need a good coverage, clear signal, and well-placed access point. So next is 4.1, signal strength and coverage. Signal strength and coverage are essential for access point to ensure stable wireless connection. Strong connection means the AP provide enough coverage and signal strength for all devices to connect well. This leads to the fast and reliable connectivity, enables smooth communication between device and application. A long signal ensures the wireless signals reach device reliability and quickly. Good coverage shows the AP is positioned and configured properly to reach all devices successfully. So for this part, these are the signal coverage that we are already put for each floor of the office. For level figure 1 is for ground floor, in the middle is for level 1, and figure 3 is for level 3. So the next part is signal noise ratio, SNR. The signal to noise ratio is the ratio of signal strength to background noise. It is used to assess the quality of a signal, with higher value indicating better quality and lower value indicating poorer quality. The signal to noise ratio improves signal detection. It has a wide range of application, including communication, system, audio, and image processing, and scientific measurement. The first point is the communication system. A high signal to noise ratio in wireless communication system suggests a strong, clear signal with little noise interface. It affects data transmit rate and mistake rate by evaluating the communication link dependability and quality. Next, audio and image processing. SNR is used to evaluate the fidelity of the replay signal or image in the audio and image processing application. Sharper visual and crisper sound are guaranteed by a greater SNR, but distortion of artifact might arise from a lower SNR. So next part is 4.3, signal strength by access point. Low signal strength and inadequate coverage from the AP can lead to several issues that negatively impact network performance. Weak and unstable connection and slow data transfer rate. Below, here are the detailed explanation of the consequence and solution. Proper AP placement and configuration identify interface. So basically, we can see from the left side of the figure is all of the AP from ground floor. We'll see the average or signal strength for each AP from ground floor, level 1 and level 2. So the last part is 4.4, network performance. Network performance refers to how well data travel across a wireless network. It encompasses dependability, speed, delay, customer satisfaction. To make it good, you need a strong signal, minimal interference, smart bandwidth usage, smooth traveling, tight security, and regular monitoring. This guarantees that users have dependable connection, support for critical tasks, and a seamless experience. So, here's some of the examples for the network performance. We have signal and strength coverage, QoS or quality of service, bandwidth management, wireless security, and capacity planning. So that's all from me. Thank you.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is Ahmad Fakhruddin bin Mohsin. 2020 831754 from EPTJ. Act as a project manager of the group project. I'm going to be present about recommendation and conclusion, which is we start for the recommendation. Firstly, recommendation of the project is network optimization. An organization or business can optimize network performance to meet their specific requirement and needs. Network optimization improve performance, efficiency, downtime, cost saving, security, compliance, and efficiency. Next is quality of service prioritization. QoS is a technique used in computer network to manage their delivery data packet based on their importance or the requirement of different application user. The goal is to ensure that critical or time-sensitive data receive preference treatment over less important or delay tolerance traffic. So it also have a two key point. Number one is point-to-point traffic management. Network management remain crucial regardless of the delivery method, be it end-to-end, node-to-node, or point-to-point. Point-to-point allow packet to be delivered sequentially without loss. Next, latency reduction. Latency is the time network requests take from sender to receiver, largely affected by router processing time and storage delay from intermediate switch. QoS allow organization to reduce latency by prioritize critical application. Recommendation number 3 is a network redundancy. Nowadays, staying connected to the internet is necessary. However, network issue can sometimes disrupt our online activity, leading to frustration and lost productivity. To ensure uninterrupted connectivity, network redundancy eliminate a single point of failure. Network redundancy is in a wireless data plan ensure uninterrupted connectivity. Redundancy also include multi-network coverage, seamless failover, load balancing, priority network selection, and enhanced reliability. Enhanced connectivity minimize downtime to achieve optimal network performance and save their money on the organization. Next is conclusion.
So for the last slide is conclusion. The network administrator has resolved the lag in network data and produced an analysis of the network diagram. So the signal interface was minimized by positioning access point for reliable and fast internet connection. Then the IP address and subnet of each access point are assigned. There are also wireless standard and separate channel for the access point on the network. So the Wlan scheme can be used for developing additional features such as improving security, durability, and efficiency. So that's all from us. Thank you very much.